In this video, we will deal with the quadratic equations and how to approach problems of quadratic equations. An equation is a statement with an equal sign stating that two expressions are equal in value. Examples. An identity is an equation which is always true, no matter what values are substituted. Examples. Solving an equation means finding the value or values for which the two expressions are equal. This value or values will make an equation true or correct. Example. Solve the following equations. Let's solve this equation by isolating the unknown. Divide both sides of the equation by the coefficient and take the square root of both sides of the equation. In this equation, remove the common factor x. When is product of numbers equals 0? When at least one factor equals 0. Let's factorize the quadratic equation and find the roots. Let's factorize the quadratic equation and find the roots. Many quadratic equations cannot be solved by factoring. This is generally true when their roots are not rational numbers. In these cases, we use of the quadratic formula. In this equation, there is the new wrinkle of variables in the denominator. This means that we will need to keep track of the values of x that would cause division by 0. These values cannot be a part of our final answer In this case, the denominators tell us that our answer will have the following restriction. X cannot be minus 4 and x cannot be 7. Now remove all the fractions by writing the equation in the equivalent form. Example. Represent each situation using an equation, then solve the equation. Remember that consecutive integers are 1 unit apart, so our numbers are x and x plus 1. Multiplying to get the product, we get x squared plus x is 20. Let's solve this equation. The numbers must be positive integers. Let x be the required number, then its positive square root is square root of x. The difference between a number and its positive square root is 12. X equals 9 does not satisfy the condition given in the question. Hence, the required number is 16. The sum of a number and its reciprocal is 26 over 5. Let's solve this equation by splitting the middle term. Therefore, the numbers are 5 and 1 over 5. Let's draw the triangle. The base length of a triangle is 2 centimeters more than its height. We need to solve this area equation. Expand the bracket. We cannot have a negative height. Let's draw the shape. The height is defined in terms of the width, so let x stand for the width of the shape. The height is 4 over 3 the width. Now we need to solve this area equation for the value of the width. We cannot have a negative width. The first thing we need to do is draw a picture. Since we don't know how wide the path will be, we will label the width as x. Looking at the picture, we see that the total width will be 12 plus 2 times x, and the total length will be 16 plus 2 times x. Then the new area is given by this quadratic is messy enough that we will not bother with trying to use factoring to solve. We will just go straight to the quadratic formula.